China says this factory can build one humanoid robot every 30 minutes. In California, Figure says it has already cut production time from one robot a day to one every hour. Tesla is promising something far bigger, not thousands of Optimus robots, but eventually millions. But the real race is not about who can make the best robot video. It is about who can manufacture these machines, deploy them, repair them, and make the economics work. So are humanoids finally becoming real workers? Or are we learning how to mass-produce the world's most expensive demonstrations? This is Blackbox Atlas. For years, humanoid robots were judged by what they could do on a stage. Walk, dance, recover from a push. China's new production lines change the question. How quickly can they be built? Leju says its automated line has annual capacity above 10,000 units. It uses 24 digitized assembly processes and 77 inspection and testing procedures. The headline number is one finished robot every 30 minutes. That sounds decisive, but capacity is not the same as output. Output is not the same as sales. And a robot delivered is not automatically a robot doing useful work. And this is where China's biggest advantage, and its biggest unanswered question, begins. To understand China's factory advantage, look beneath the robot. A humanoid is not one machine. It is a walking stack of motors, gearboxes, batteries, sensors, castings, circuit boards, and precision-machined parts. China already manufactures these components at enormous scale. Robot companies can iterate close to their suppliers, replace parts quickly, and push prices down. Unitree advertises its G1 starting at $13,500. That number changed the conversation, but it does not buy a complete employee. Dexterous hardware, integration, maintenance, and software can move the reel. Cost much higher. America's answer is to pull more of the supply chain inside the factory. At 1X in California, more than 200 people build motors, batteries, hands, structures, and transmission systems under one roof, the company says. The facility has capacity for 10,000 NEO robots a year, while a second factory and more automation are intended to push that number toward 100,000. And notice who appears in these images. People. Machinists, assemblers, technicians, and quality inspectors. Before robots can replace factory workers, thousands of skilled workers may be needed to build, test, and repair the robots themselves. Figure is following a similar strategy. Its BotQ factory says it has delivered more than 350 Figure 03 robots and demonstrated one robot per hour cycle time. But Figure describes every new robot as something more than inventory. It is a data collection machine, another body teaching the software how the physical world works. China may have the hardware advantage. The American bet is that intelligence, data, and rapid iteration can close the gap. That bet only works if the robots can survive outside the demonstration room. Outside the demonstration room, the story becomes much less cinematic. At BMW's Spartanburg plant, Figure 02 worked on the assembly line and, according to Figure, contributed to the production of 30,000 vehicles. That does not mean the robots built 30,000 cars. It means they performed one part of a much larger human and machine process. Figure 03 is now being demonstrated on a more difficult sequencing task, selecting parts that may arrive shifted, rotated, or partly hidden, then placing them in the correct order while moving heavy carts. This is where a humanoid can make sense. Not because two legs are always better, but because factories, tools, and workstations were designed around the human body. In China, AgiBot recently broadcast several robots working for 6 days on a real tablet production line. The company reported more than 64 hours of operation, almost 65,000 completed tasks, and a success rate of 99.99%. Those numbers are impressive. They are also company reported, and they leave out the number every factory manager eventually asks. How much money did the robots actually save? A successful deployment must include the cost of integration, supervision, maintenance, charging, downtime, and every human intervention. A robot that works beautifully for 20 minutes but needs an engineer for the next hour is not cheap labor. It is an expensive research project. Traditional automation still wins when a task is fast, fixed, and predictable. A robotic arm does not need a face, 2 legs, or artificial general intelligence to weld the same joint 10,000 times. The humanoid only earns its complexity when the environment changes. Different boxes, different parts, different positions and jobs that move from one workstation to another. So the metric that matters is not robots produced. It is productive, unsupervised hours per dollar. And by that measure, nobody has won the race yet. Tesla makes everybody else's production plans look modest. In its latest quarterly update, the company described an Optimus line in Fremont designed for 1 million robots a year. That line is expected to replace the space used for Model S and Model X production. A second-generation line in Texas is being designed around a long-term figure of 10 million a year. Read the wording carefully. Tesla is preparing factories and installing its first production lines. Those capacity figures describe the scale of the equipment being planned. They do not describe robots currently leaving the factory. Tesla has good reasons to think big. It already knows how to design products for automated assembly, negotiate huge component contracts, and drive manufacturing costs down over several generations. Very few robotics companies have anything comparable to Fremont or Gigafactory Texas. Optimus will still be a difficult product to ramp. A car stays on 4 wheels and repeats a limited set of physical actions. A humanoid has dozens of joints, 2 complicated hands, and a habit of falling onto expensive things. Small changes in weight, balance, or cable routing can alter the entire assembly process. The software problem is just as awkward. Billions of driving miles can teach a system a great deal about roads. They do not teach a hand how to separate 2 thin objects in a crowded bin, recover a dropped tool, or decide when to ask a nearby worker for help. Tesla is building capacity before anyone has proved how large the paying market will be. That approach worked spectacularly with electric cars. Robotics may follow the same path, although the evidence is still thin. For now, Tesla has the largest manufacturing ambition in the race. Leju and Unitree have visible hardware moving through Chinese factories. Figure and 1X are building smaller fleets and feeding the results back into their designs. Factory plans reveal what these companies want to become. Shipments, uptime, and paid work will reveal how far they have actually traveled. After looking at the factories, the deployments, and the numbers, China is currently ahead in humanoid manufacturing. Its companies have access to a dense hardware supply chain, lower component costs, and production lines that are already turning out physical machines. They can place more robots in more environments, discover failures, and revise the hardware quickly. That lead comes with an important qualification. We still have little public evidence of a general-purpose humanoid completing an entire factory shift with minimal supervision and producing a clear financial return. Among the American companies, Figure has shown the most concrete industrial progress. Its fleet is smaller, although the work at BMW gives it a useful place to test hardware and software together. 1X has built a serious manufacturing base for NEO, while its difficult home robot promise remains largely untested with customers. Tesla could change the ranking. It has factories, capital, and experience, turning expensive prototypes into mass-market products. Its Optimus plans are still plans. We need production figures and long-duration deployment data before treating the proposed capacity as an accomplished fact. So yes, Tesla and Figure can catch up. China's lead is early, and robotics programs can lose years when a hand, gearbox, or training system fails to scale. The opposite is also true. Excellent software cannot generate revenue while the hardware is unavailable. During the next few years, useful humanoids will probably work inside narrow jobs with people nearby. Service teams will monitor them, software will improve. Between shifts, and factories will learn which tasks are worth automating. The most convincing robot video may eventually look quite boring. One machine, on an ordinary Tuesday, finishing the same useful job for 8 hours without an engineer stepping into frame. China leads the production race today. The race to build a profitable robot. Worker is still open. Which company would you trust to get there first?